Hello friends, myself Dr. Akhilesh. In this video, I will discuss the important MCQs on pH and buffers. This topic is important from the NEET, NEXT, INI, CET, FMGE, USMLE and other entrance examination point of view. So let us start the questions. The first question is, if the pH of a solution changes from 7 to 2, then the concentration of hydrogen ion. So the concentration of hydrogen ion will increase or decrease, and if it increases or decreases by how much times. So to solve this question, we need the knowledge of this table here. So you can see in this table that in this table here it is written as the pH scale. The pH scale is from 1 to 14, and the corresponding hydrogen ion is mentioned against these pH values. So in this you can see here that if the pH is 1, then the concentration of hydrogen ion in mole per liter is 10 raised power minus 1. If the pH is 2, the concentration of hydrogen ion is minus 2. Similarly, if the pH is 7, the concentration of hydrogen ion is 10 raised power minus 7. And similarly, if the pH is 14, the concentration of hydrogen ion is 10 raised power minus 14. So you can see in this table that if the pH increases by 1, then you can see here that the concentration of hydrogen ion decreases 10 times. And what is the vice versa? The vice versa is that if the pH is decreasing by 1, then you can see here that the concentration of hydrogen ion increases by 10 times. So in this, the question is asking that if the pH changes from 7 to 2. So pH is changing from 7 to 2. So what is the concentration of hydrogen ion at the pH 7? The concentration of hydrogen ion at pH 7 is 10 raised power minus 7. And what is the concentration of hydrogen ion when the pH is 2? So when the pH is 2, the concentration of hydrogen ion is 10 raised power minus 2. So in this you can see here that if the pH changes from 7 to 2, what is happening to the concentration of hydrogen ion? So this concentration of hydrogen ion is increasing. So this concentration of hydrogen ion is increasing, and it increases by how much time? So you can see here the difference between 10 raised power minus 7 and 10 raised power minus 2. The difference is the 10 raised power 5. So when the pH will change from 7 to 2, then the concentration of hydrogen ion, it will increase by 10 raised power 5 times. So now let us look at the options here. So if the pH changes from 7 to 2, then the concentration of hydrogen ion, it will increase, but increases by how many times? 10 raised power 5 times. So this is the correct answer here. So remember here, if the pH is changing or pH is increasing by 1, so pH change from 1 to 2, the concentration of hydrogen ion is 10 raised power minus 1, and at 2 the concentration of hydrogen ion is 10 power minus 2. So pH increases, right? If the pH increases, the concentration of hydrogen ion will decrease by 10 times. And if the vice versa, that if the pH is decreasing by 1, then what will happen to the concentration of hydrogen ion? The concentration of hydrogen ion will increase by 10 times. So remember this concept in this to help to solve this question. Now come to the second question. The second question is normal pH of the blood. Means you have to know the pH value of some body fluid. So let us have a look on the table, which is important from the various examination point. So you have to remember about the pH of various fluid in the body. So in this table I have mentioned all the important body fluids and their pH value. Let us see them. The pH of the urine. The pH of urine is 4.5 to 8.0. Cerebrospinal fluid CSF, it is 7.33. Gastric juice, its pH is 0.8 to 3.0. the average is 1.2 and it has the lowest pH or the least pH. So this is the most acidic fluid. So gastric juice is the most acidic fluid, and the pH of the arterial blood is 7.35 to 7.45. You can also say here that it is 7.4 plus minus 0.05. The pH of the pancreatic juice is 7.8 to 8.4, hepatic duct bile 7.8 to 8.6, saliva. During the resting state, the pH is 6.0 to 7.0, and during the active state or active secretion, it is 7.0 to 8.0. The small and large intestinal secretions, the pH is 7.5 to 8.0. RBC or the cell, the pH inside them is 7.20. The venous blood pH is 7.36. In some books it is given as 7.35 also. The pH compatible with life is 7.0 to 7.7. In some books it is also given as 6.9 to 8.0 also. The gallbladder bile, the pH of the gallbladder bile is 7.0 to 7.4, and the bile it is 7.8. The Brunner's gland secretion, the pH is 8.0 to 8.9. So in this one you can see here that the Brunner's gland secretion, it has the highest pH. The Brunner's gland secretion, it has the highest pH, and the gastric juice has the lowest pH. So in the question it has been asked that the normal pH of the blood is. So normal pH of the blood is how much? It is 7.40 plus minus 0.05. So the range will be from 7.35 to 7.45. So this is the range of the pH of the blood. So in this option the answer C is correct. And also you have to remember about the two terms here. One term is called as acidosis. If the pH of the blood is less than 7.35, it is called as acidosis, and if the pH of the blood is more than 7.45, it is called as alkalosis. So remember these two words, acidosis and alkalosis. So normal pH 7.35 to 7.45. If the pH is less than 7.35, it is called as acidosis, and if the pH is more than 7.45, so it is called as the alkalosis. So remember these two terms, acidosis and alkalosis. Now let us look at this another question here. Which of the following has the highest pH? So in this types of question you have to know the fluids which are having the very high pH. So in this, let us to solve this question here, let us go again the table here and we will find which has the highest pH. Highest pH means, remember one thing also, the highest pH means it is asking about the most alkaline. So most alkaline fluid, it has the highest pH, right? And also remember here the lowest pH means what? So lowest pH means what? It is the most acidic here, right? So remember this, do not confuse with this term. So highest pH means most alkaline and lowest pH means what? Most acidic. So in the option gastric juice, gallbladder bile, pancreatic juice and CSF has been asked, we have to find out which has the highest pH. So let us go ahead and see the table here. The gastric juice pH is 0.8 to 3.0, CSF it is 7.33, pancreatic juice it is 7.8 to 8.4, the gallbladder bile it is 7.0 to 7.4. So we have been asked which of the following has the highest pH. Of the given options, so this pancreatic juice, it has the highest pH, right? So pancreatic juice has the highest pH of the given options. But remember, the Brunner's gland secretion is 8.0 to 8.9. So it has the highest pH, but it is not given in the option. It is not given in the option. So and also see here the hepatic duct bile, its pH is 7.8 to 8.6. It is also has very high pH. Remember, but it is also not given in the option. So out of this, the gastric juice, out of the CSF, out of the pancreatic juice and the gallbladder bile. So out of these four options, the pancreatic juice has the highest pH. So our answer will become pancreatic juice in this question. Right. So highest pH, the pancreatic juice will be the answer here because its pH is 7.8 to 8.4. So our answer will be C here. The pH of the gastric juice is 0.8 to 3.0. It has the lowest pH. It is lowest pH and it is the most acidic fluid. Right. So it is the most acidic fluid in the body. Gallbladder bile 7.0 to 7.4 and the cerebrospinal fluid 7.33. So of the given options, pancreatic juice is the correct answer. And remember, in terms of the highest pH, the question is on the highest pH like this one. So Brunner's gland secretion, which pH is 8.0 to 8.9, this fluid has the highest pH. And where are the Brunner's gland present? So these Brunner's gland, they are present in duodenum. Remember this. So they are present in the duodenum. This is also asked in the various MCQs that the Brunner's gland is the characteristic feature of. So answer will be the duodenum. So highest pH, remember Brunner's gland secretion. If not given in the option, then go for the hepatic duct bile, whose pH is 7.8 to 8.6. If not given in the option, then go for the pancreatic juice, which pH is 7.8 to 8.4. So in this question, Brunner's gland not given, hepatic duct bile not given, so answer will be what? Pancreatic juice, right? Then let us look at another question here. Again, which are the following as the highest pH? So highest pH, I told you that highest pH, look for the Brunner's gland secretion. If not given, then look for the hepatic duct bile. If not given, then look for the pancreatic juice. Let us look at the options here. The gastric juice, gallbladder bile, pancreatic juice and hepatic duct bile. Here the pancreatic juice is also given in the option and hepatic duct bile is also given in the option. Which one has the highest pH here? Out of the hepatic duct bile and pancreatic juice, the hepatic duct bile pH is 7.8 to 8.6. This is more than the pancreatic juice pH, which is 7.8 to 8.4. So our answer will be what? So again we can see the table here. The gastric juice is 0.8 to 3.0, pancreatic juice 7.8 to 8.4, hepatic duct bile 7.8 to 8.6, gallbladder bile 7.0 to 7.4. So our answer here will be the 7.8 to 8.6, that is the hepatic duct bile. So hepatic duct bile will be our answer here in this question. Remember here in this question, the Brunner's gland secretion is not given. If that would be the option, then we have to go for that one. Right. Now let us look at another question here. Which of the following is most acidic? Now it is having the lowest pH. So most acidic. So in the previous questions also I have mentioned here, the most acidic means which has the lowest pH. Which has the lowest pH here. So I have told you that the gastric juice secretion, the pH is 0.8 to 3.0, average is 1.2, right? And this has the lowest pH in the body. The pancreatic juice, I have told you the pH of the pancreatic juice is how much? The pancreatic juice pH is 7.8 to 8.4. The gallbladder bile 7.0 to 7.4, hepatic duct bile 7.8 to 8.6, and the gastric juice is 0.8 to 3.0. So most acidic or having the lowest pH, our answer will be the gastric juice. Now let us look at the another question. So now this question is on the value of this pK. pK means the dissociation constant here. The amino acid with its pK value within the physiological range. The physiological range means the pH value is near around the pH of the blood, that is 7.4. So of these given options, which one has the pK value near around the pH of our blood? So let us look at this table here. So amino acid and the range of this pK, dissociation constant. The aspartic acid and the glutamic acid, their pK value is 4.0 to 4.8. Histidine, the pK value is 7.4. This is near to this the pH of the blood. The cysteine, it is 8.5 to 9.0, too much high than the pH of our blood. Tyrosine, again, this also has very high pK value, 9.5 to 10.0. So of these given options, the histidine. So this histidine, the pK value is near the pH of our blood. So our answer will be the histidine. So amino acid with its pK value within the physiological range will be the histidine. The pK value is 6.5 to 7.4. The remaining option B, C and D, the aspartic acid pK value 4.0 to 4.8. It is less than the pH of the blood. The cysteine and tyrosine, which pK value is 8.5 to 9.0, and this tyrosine 9.5 to 10.0, these two, they have the pK value more than the pH of the blood. And this aspartic acid, its pK value is less than the pH of the blood. So now this histidine is near around the pH of the blood. So this will have its pK value within the physiological range. So answer will be A, histidine. Now let us look at another question here. The amino acid responsible for buffering action of the hemoglobin. Direct question here. Remember this, the hemoglobin has one amino acid called as histidine. So this histidine in the hemoglobin is responsible for the buffering action of the hemoglobin. So remember here H for the histidine and H for this hemoglobin. So H for hemoglobin. So this, the buffering action of this hemoglobin is due to this amino acid histidine. This is a direct question, you have to remember this. Now let us look at the another question here. The another question is, at physiological pH, the buffering action in the blood is done by. So buffering action in the blood is done by the various substances, but here in this question it is asking about which amino acid is responsible for the buffering action in the blood. So which amino acid will be there? So the answer here is the histidine. This histidine is present. It is present in this hemoglobin, and it is causing providing the buffering action of this hemoglobin and RBC. So the buffering action in the blood out of these amino acid, the correct answer is the histidine. Now the another question is the most important ECF buffer. ECF means extracellular fluid buffer is. So remember this, the most important ECF buffer system is the bicarbonate system. So bicarbonate system is the most important buffer system of the ECF. So this bicarbonate is the most important buffer system of the ECF. Remember this point here. It is asked in many entrance exam also. The hemoglobin is the important buffer system of the blood, or you can also say that the RBC, because hemoglobin is present in the RBC, so it forms the important buffer system for the RBC, and RBC are present in the blood, so it will form the important buffer system in the RBC and the blood. The plasma proteins, they are present in the plasma, and you also know that the ECF is made up of, so ECF is made up of the plasma plus the interstitial fluid. So it will interstitial fluid. So the plasma proteins, so they will act as the important buffer for the plasma, but the ECF include this interstitial fluid also. So this will not be the correct answer here. The phosphate system is present in the renal tubules. It is the important buffer system in the renal tubules and inside the cell or intracellular fluid. So but in this question it is asking about the important buffer system of the ECF. The important buffer system of the ECF is the bicarbonate system. So this is the correct answer here. So the correct answer here is the bicarbonate system. So this is all about the various important questions on the pH and the buffer system. And to No more or more questions on this physiology. So visit this page physiology MCQ on the Facebook, and you can also find the original questions from the various entrance exam in the book Conceptual Physiology Review CPR, which is available on the Amazon. So you can order from the Amazon and you can have go through this various questions based on this the next NEET, FMGE, INI-CET. So thank you very much for watching this video. If you like this video, then subscribe my channel and do not forget to press the like like button there, and also press the bell icon on my channel. So thank you very much for watching my video.